Hi everyone. In this lesson we're going to continue proving congruent triangles using the side angle side criteria, but today we're also going to include the properties of the isosceles triangle in the proofs. So we start by reviewing the isosceles triangle. First, the definition. An isosceles triangle is a triangle that has two congruent sides, and we have to remember that those sides that are congruent, they are called the legs, and the other side is the base. Very important to also remember that the angle that is formed by those two congruent sides is called the vertex angle. So if you know which one is the vertex angle, you should know which one are the congruent sides. So for example, here we have, if you were given this isosceles triangle ABC with vertex angle A, then you should be able to conclude the two sides that are congruent. So if you are given isosceles triangle ABC with vertex angle A, then your conclusion would be which one are the two congruent sides. So that would be AB congruent to AC, and the reason would be the definition of the isosceles triangle. Okay, because we go very strictly by what the definition says. The definition, one more time, says an isosceles triangle is a triangle that has two congruent sides. So if you have an isosceles triangle, the only thing that you can get are two congruent sides. That's it. You cannot get anything else. You can get two congruent sides. And for that, you need to be able to identify which one is the vertex angle, in this case, angle A. So next one, the base angles theorem. If two sides of a triangle are congruent, then the angles opposite them are congruent. So from here, if you have two congruent sides, you can get two congruent angles. So if you have an isosceles triangle, like in number one, you cannot jump immediately and say, I have two congruent angles. No, because the isosceles triangle just gives you two congruent sides. In order to get two congruent angles, you need two congruent sides. So first you need to have two congruent sides, and then you can say that you have two congruent angles. So in this case, the theorem says that if you have two congruent sides, you can conclude that you have two congruent angles, and the angles that are opposite them are congruent. So in this case, angle A would be congruent to angle C. So if you are given that AB is congruent to BC, then you can conclude that angle A is congruent to angle C, and the reason would be the base angles theorem. Or if you prefer, you can write what the theorem says. You will have to write the whole statement here, but for short, we can just say base angles theorem as the reason. The next one, the converse of the base angles theorem is basically the opposite of the base angles theorem. So the base angles theorem starts with two congruent sides, and that helps us to conclude that two angles are congruent. Here's the opposite. So the theorem says if two angles of a triangle are congruent, then the sides opposite them are congruent. So we start with these two angles congruent, and we can conclude that the sides opposite them are congruent. So if you are given, or if you have that angle A is congruent to angle C, you can conclude that AB is congruent to CV, and that will be by the converse of the base angles theorem. And finally, something completely new, but not really completely new. We have known this since the transformation unit. CPCTC stands for corresponding parts of congruent triangles are congruent. So we learned that from the transformation unit. We know that if two figures are congruent, then that means all the corresponding parts, all the corresponding angles, and all the corresponding sides are congruent, if they are congruent, if the figures are congruent. So if, for example, you are given in a proof, you are asked to prove that angle T is congruent to angle B, the only way to prove that parts such as angles or sides are congruent, the only way to prove that parts are congruent is by first showing that the two triangles are congruent. There's no other way around. So if you were given this, the first thing that you will need to prove is that triangle TXR is congruent to triangle BXS by whatever reason, whatever method that you are using. So far, we only have one method, which is the side angle side. So let's say we prove that the triangles are congruent by side angle side. Then you can immediately say angle T is congruent to angle B. And the reason would be CPCTC, which means that because the triangles are congruent, then these parts are automatically congruent. Because all the corresponding parts of congruent triangles are congruent. Not really only triangles, this would apply for any congruent figures, but since we're working with triangles, this is modified only for triangles. And the same thing could be done if, for example, you are being asked to prove, for example, side TR being congruent to side BS. If you have to prove that two sides are congruent to segments, then you will have to do exactly the same way. First, you prove that the triangles are congruent, and then you can state that those two sides are congruent by CPCTC. So these are the things that we need for our proofs today. And now I'm going to page number 1 of the document that you have. So on page number 1, on top of page number 1, you see here the box with all the things that I already discussed. So this is what you have. And then I have 4 proofs. So let's go to proof number 1. So it says, given triangle TRS is isosceles with angle R as vertex angle, as the vertex angle, and SY congruent to TZ. So that's all given. Your job is to prove that angle SRY is congruent to angle TRZ. So your job is to prove that this angle here, the little angle there, is congruent to this little angle here. I'm not marking them congruent because right now we do not know that they're congruent. We have to show that they are congruent. And we're given that triangle TRS is an isosceles triangle and R is the vertex angle. So what can we get from that? Well, as I discussed on the top, if you have the vertex angle in an isosceles triangle, you have to be able to get two congruent sides because that is what the definition of the isosceles triangle says. So if this is our vertex angle, then the two sides that form that angle should be the sides that are congruent. So we know from that given that this is congruent to this. And if you want to prove that these two angles are congruent, you are going to have to prove first that these two triangles here are congruent. So let me sort of highlight them. So this triangle must be congruent to this one in order to say that these two angles are congruent. So our job would be to prove that these two triangles are congruent. And look at what we have. We have here these two sides being congruent because we know the vertex angle is R. And what else can we get? Well, think about the base angles theorem now, because we have two congruent sides, and the base angles theorem says that if you have two congruent sides in one triangle, then the angles opposite the sides should be congruent. So that would make angle S, which is opposite side RT, congruent to angle T, which is opposite to side RS. So that's what we have. Because of the base angles theorem, we know that this angle is congruent to this angle. Okay, so only from the first given, we got these two pieces of information, which is the side and the angle, side and the angle. And we're just missing one side because the only method that we know so far is side angle side. We already have a side, the angle, and now we're just missing the side, but that is given also as well. And so it says SY, which is this little piece here, is congruent to TZ, which is this little piece here. And we have everything that we need. We have side, angle, side. Side, angle, side. Remember that the angle has to be in between the two sides for this method. And so we have that method. With that, we can conclude that these two green triangles are congruent, and therefore, because they're congruent, these two little angles here would be congruent. So that's the plan. We already know what we're going to write. I'm just going to write the proof now. And I have my first given already written here. Isosceles triangle TRS with vertex angle R. I modified it a little bit so to make it a little bit shorter. You can do that always. And that was given to us. And now I'm not going to put here the second given. I'm going to put here what I got from the first given. We usually in the proofs don't write all the givens together at the beginning. We write them as we need them. So there is a conclusion that we can get from the first given. So I'm going to write that conclusion. The conclusion was that there are two sides that are congruent because from an isosceles triangle, you can get two sides that are congruent. And the sides were RT congruent to RS, and that is by the definition of the isosceles triangle. And now there was something that I got from these two sides being congruent, so I'm going to write that here because there is a conclusion that comes from there. So what do we get from these two congruent sides? We got that we have two congruent angles, which is angle S congruent to angle T, and that was by the base angles theorem. Remember that whenever you have one angle in a vertex, you can just use one letter to name the angles. But if you have more than one angle, like in this vertex or in this point Z, you have more than one angle, you cannot say angle Z to this one here. And then I got everything that I can get from this given. I don't have anything else. So now I include the next given, which is that SY is congruent to TZ, and that's given to us. And with this, we have side angle side. I have here one pair of congruent sides. I have here one pair of congruent angles. I have here another pair of congruent sides, specifically stated as such, two sides being congruent, two angles being congruent, two sides being congruent. Therefore, I can make the conclusion that triangle RYS is congruent to triangle RZT because of the side angle side criteria. And now that the two triangles are congruent, now I can say any parts are congruent. In this case, we're talking about angle SRY being congruent to angle TRZ. So angle SRY congruent to angle TRZ by CPCTC, which means that because the triangles are congruent on the previous step, we know that these angles are congruent because all the corresponding parts of congruent triangles are congruent. Okay, so that is how we prove, in this case, that two angles are congruent by first proving that we have congruent triangles. So I'm going to briefly discuss exercise number 2. Okay, so here you are given that segment BA is congruent to segment CA and AX, segment AX bisects angle BAC. And your job is to prove that angle AVX is congruent to angle ACX. So first of all, let's identify what are the things that you have to prove. And it's angle ABX, this little angle here, congruent to angle ACX, being congruent here. So your job is to show that this angle is congruent to this angle. And in order to do that, first you will need to show that this triangle here is congruent to this triangle here. That's the only way. Now we identify what we're given in order to do the proof. And we're given that BA is congruent to CA. So you don't have to identify from the vertex angle. It's already given to you in this case. So it's BA congruent to CA. And then you're given that AX bisects angle BAC. Now, of course, you might want to say, because these two sides are congruent, then the angles opposite them are congruent, which would be the big angle here, this big angle, the complete angle, with this complete angle here. But it happens that we only need to prove these little triangles here congruent. So saying that, or obtaining the two angles congruent from these two congruent sides is not going to help us here. So we're not going to say, as we did in the last proof, this big angle BABC is congruent to ACB by the base angles theorem. We cannot use that here. Instead, we have other pieces of information, such as that AX is the bisector of angle BAC. So this angle BAC is being bisected. And we know that when an angle is bisected, it's divided into two congruent angles. And so we need to identify what are those two congruent angles. So it's going to be this little angle here, congruent to this little angle over there. And so we have side, angle, because we are only using side, angle, side. And we're just missing a side. But you can see in the diagram that AX is being shared by both triangles. So you already have here the other side by the reflexive property. And that's it. You have everything to prove that these two triangles are congruent. And after that, you can state that these two angles are congruent because of the corresponding parts of the congruent triangles. And I'm going to go now to page number 2 to look at exercise number 3 very briefly. So in this case, you are given triangle KJL with angle K congruent to angle L, and you're also given that segment KX is congruent to segment LY. Your job now is to prove that segment JX is congruent to segment JY. So let me first identify what is it that you have to prove. You have to prove that this segment here, JX, is congruent to segment JY. So I'm going to put the dots over there. This one congruent to this one. That is what you have to show. And of course, in order to do that, first you'll need to prove that these little triangles here are congruent. Look at what you're given. You are given that these two angles here, K and L, are congruent. Since you have two angles congruent, now you can use the converse of the base angles theorem to get two congruent sides. So that will make JK congruent to JL. And then you have this little piece here that's also congruent. In number 4, the givens are very similar to what we have seen before. Like this one, I think was improved number 1, and this one improved number 2. So you can use this, and your job here is going to be to prove that CD is congruent to segment BD, the same thing as with the angles. First, you need to prove that you have two triangles that are congruent, which in this case are going to be these two triangles that you see over there. If those two triangles are congruent, then you can state immediately that these two parts are congruent by CPCTC. Only remember here that, and in all the cases, that we're using side, angle, side because that's the only method that we have learned so far, and that the angle that we use must be in between the two sides. Okay, so I'm going to leave proofs 2, 3, and 4 for you to finish as the homework, and that will be for today's lesson on how to prove triangles congruent using side, angle, side, and also how to include the properties of the isosceles triangle and CPCTC in the proofs.